It's okay, you can't hear your voices, you can only hear mine. Okay, so when we did this, when we graphed, ooh, this is all different, hold on.
Sorry,
It's all good.
I have it different than you.
Okay, so when you graph this, we graph x squared. Your vertex is always going to be right in the middle in our origin. Then the pattern was what? Right 1, up 1. So right 1, up 1. So if you forgot that, write it out. Right 1, up 1. Okay, then it was right 2, up what? 4, because 2 squared is 4. So right 2, up 1, 2, 3, 4. And because it's symmetric about that line, that y-axis, we can just go ahead and reflect it on over. And that was our square root function. Now again, you could have plot all those points off to the side, and that would have been just fine if you got stuck on that, if you didn't remember the pattern. Okay, now let's talk about cubed. It was right 1. I'm just going to put r for right, so I don't have to write it out every time. It was right 1, and then it was up what? 1. So right 1, up 1. Okay, then we went right 2, up what? 8, because 2 cubed is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, now when you think about cube roots, would I draw the other side in the second quadrant or the third quadrant? The third, yeah. So you're just reflecting that over. It's the same thing. So we'd be going left 1, down 1, left 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the pattern. Or if you got stuck, you're more than able to put that in your graphing calculator and get some points, or to actually put in the numbers yourselves and putting in the points as well. Okay, so now we're going to ask ourselves, are the inverses also functions, and how do you know? So let's talk about the very first one. Is the inverse of a quadratic a function? No. So the x squared is not. Inverse, not a function. And then what about x cubed? Yes. Okay, it's not a function because it does not pass that horizontal line test. And that's when we had to restrict the domain. Okay, we're going to see that a little bit more today because we're actually going to start looking at what a square root function looks like. We haven't really done that yet. We've seen them, but we really haven't really gone in depth with them yet. Okay, do you have questions on those? Okay. Now let's look at this. And some of you had questions on your cognitive tutor when you did this, because we were doing transformations on cognitive tutor with radicals. We really haven't done it yet. But let's do ones that we already know. Okay, so remember, our pattern is always right 1, up 1. Okay, so instead of going right 1, well, no, let me start over. What is the vertex of this graph? Because that's going to be the huge key here, because then you can do your pattern. Yeah, so I'm going to actually write that out. My vertex is going to be 3, -4. So let me graph that. 1, 2, 3, down 1, 2, 3, 4. And guess what? Once you graph that point, you can now do your pattern that we're used to. Okay, so we're still going to go right 1, up 1. We're still going to go right 2, up, well, 2 squared, 4. So right 2, up 1, 2, 3, 4. Now remember, it's symmetric about that x value of your vertex, so we're just going to go ahead and draw the other side of it. So here and here. If you ever get stuck and you forget the pattern, you're more than welcome, like I said, to start putting some points in here. But I highly recommend at least plotting your vertex first, because the vertex is going to be key. You're going to have to be able to get points on the right of it, on the left of it, to make sure that you're graphing that correctly. Okay, do you have questions on that one? Okay, try 1B. Okay, so it's just like this one, but now you're doing cubed. Okay, so it's the same thing. You have to plot that inflection point. It's not called the vertex, it's called the inflection point. But you still do the pattern. So plot your inflection point, which is kind of like the vertex of a quadratic, and then do your pattern. And if you ever get stuck or you want to check your answers, get in your graphing calculator and say, did I graph that right? Go ahead and plug that in. Okay, that's always a great validation. We love the graphing calculator if we can use it. So let's talk about this. Some of you are still graphing. Actually, I'll give you another 30 seconds. Some of you are already flying to the next problems. It's okay. So hopefully it is easy for you because it is review, this part, this first page. What is your point of inflection for a cubic function in this situation? Good. -2, 1. So let's graph that. 1, 2, 1. Now we're going to go right back to the pattern because we're in cubic. The pattern was right 1, up 1. So here we go. Right 1, up 1. Then it was right 2, up 8. 1, 2, 3, 4, 5, 6, 7. Somewhere up here. Okay? Then same thing. We're going to go left 1, down 1. Then we're going to go left 2, down 8. So we got 1, 2, 3, 4, 5, 6, 7, 8. Okay? Again, you can always check your answers on that graphing calculator.
Make sure you pay attention to what that exponent is. If you just see an exponent, you might think, oh, it's quadratic. Make sure you pay attention if the exponent is a 2 or a 3.
Yeah. Okay, because I saw that some of you wrote vertex here, and that's, I understand why you wrote vertex, but it's technically not a vertex. It's called a point of inflection. That's where the graph will start changing the direction. Okay, now here's kind of where it gets a little tricky because we're going to be stretching or compressing. But let's first talk about this. What does this mean? This negative out in front. Yeah, it's going to be reflecting over the x-axis. What about the 2? Stretch by 2. So is that really going to be affecting my domain at all here? No. Okay, but it's actually going to be affecting like my y values because it's going to be stretching a little bit. So all you have to do with that pattern, we're still going to go right 1. But instead of going up 1, what are we going to be going up? Oh, there you go. We're going to be going down 2. Okay, so here we go. Let's plot that. We're going to go right 1, and we're going to go down 1, 2. But where is our vertex? Yeah, because nothing changed. I didn't go left, right, up, or down. Okay, I didn't move the graph at all. All I did was I made it a little skinnier. Okay, so your vertex is still at 0, 0. So if you want to make a note of that, please do so. The only time your vertex changes is if you're going to be moving left, right, up, or down. In this situation, we are not. Okay, then I'm going to be going right 2, and then what? What happens to, so originally I go right 2, up 2. What's going to happen? Right 2, up 4. Yeah, just 8 though? Am I going to be going up or down 8? Down. Very good. So right 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then I just reflect that right on over. If you ever get stuck, like I said, you're more than welcome to go ahead and plot some points. You could have just plot in -2. Well, we want the 1 point. If I put 1 squared here, you're going to end up getting our down 2 here. You're going to be getting that. You could be just putting in points. We're just trying to teach you an easy trick here. Or you've already done this, technically. Okay, go ahead and try 1D. It's kind of the same. A little different because we have that negative inside. Does anyone remember what the negative inside of parentheses mean? Reflect over the y. Very good. Okay, give it a try. See how you do. I always find my point of inflection first for this one. And we're in cubic, so you should be knowing, does it go the same direction or opposite directions? For cubic? The end behavior, does it go like both the same or do they go opposite for cubic? They're going opposite. Yeah, end behaviors of cubic functions go opposite directions if you take a look right above. See how they go opposite directions. Okay, let's try about this one because I feel like we're getting a little stuck on, what's going on with that negative inside the parentheses. Okay, so what does this 1/2 mean? What are we doing to the original function? Yeah, we're compressing. We already talked about this, but this one's reflecting over the y, which means that we're changing the x values. Okay, if we're reflecting over the y, we're going to be changing those x values. So let's talk about this one together. Again, our original pattern is right 1, up 1. So instead of going right 1, what happens? I'm going to go left 1. Very good, because again, I'm timesing it by a -1, right? Because when I put in, if I'm going right 1, I multiply it by a negative, I then am going left 1. Now, instead of going up 1, what am I going to be going? Up what? Up 0.5, yeah. So left 1, up 0.5. But where's my point of inflection? 0, 0. Very good. So I have left 1, up 1/2, somewhere like that, which means I'm also going right 1, down 1/2, because that's what cubic functions are. They always are going to be the opposite. They reflect over the origin. Okay, now I usually go right 2, up 8. What's going to happen now? Good, very good. And here's how they got that. Again, usually I go right 2, up 8. But because I have this negative, it's going to make me go left 2. And then instead of going up 8, I divide by 2 and I get 4. So I have left 2, up 1, 2, 3, 4. And then that also happens here. You can always plot your graph in your graphing calculator to make sure you're doing it correctly. If the patterns confuse you, if you get stuck, just put in some points. Okay? Always use your origin or your point of inflection as a guide. If you get stuck, just put in some points. But always, my recommendation is if you're going to do it in your head instead of with a calculator, find either your vertex first or your point of inflection, then plot some points that are like left and right of it if you don't want to do the pattern, because you can do that. But now let's do some stuff that's completely new, because we really haven't talked about what these two graphs look like. Okay. I want you guys to go ahead and put these in your calculator and get some points and just kind of investigate what it looks like. Okay, just kind of see what it looks like. If you forgot how to put this cube root in, it's math 4. So maybe just plot them. You can even put them both on the same graph. You can put one in y1 and y2 and just kind of see what they look like just to kind of investigate. You want to press math? Yeah, you're welcome. And you can even get yourself some points if you want. Hopefully you got something that looked like this for your A. Okay, remember a square root, and we investigated this a little bit already, right? So when we were talking about restricting the domain of a quadratic before your quiz, okay, we already kind of did this, because what can't we have under the radical? Negatives. That's why we can't draw the other half of that quadratic down here, because you can't have negatives under a radical. Those are imaginary numbers. They don't exist. Okay? So, make sure you have those points on there for us. Really all you're doing is you're taking perfect squares. So, let's talk about a pattern. Can you guys come up with a pattern that might be happening here? Because we like patterns. If I go right 1, what am I going up? 1, because the square root of 1 is 1. Okay, can I go right 2 and get a nice, pretty square root? No. What about right 3? No. What about right 4? Yeah, because what is the square root of 4? So there's your pattern. Okay, right 1, up 1, right 4, up 2. Now this is very interesting for a reason, because if you look back on your first page, our pattern for quadratics were right 1, up 1, right 2, up 4. Yeah. And because they're inverses of each other, it just makes sense that they just switched. Okay, that's pretty cool to see that. All right, so that's now our new pattern for our radical functions, or like I said, you can always plot some points to make sure that you're understanding it. Either one, whatever works for you. Some people really like patterns, and some people really just like putting in the numbers and figuring out what the points are. It just depends on how you feel about it. Okay, for this one, you should have got points like this if you went on your graphing calculator and wanted to plot them. And again, it makes sense that you're going to have negative numbers, because for cube roots now, you can have negative numbers. The cube root of -8 is -2. If you think about it, -2 times -2 times -2 is a -8. Okay, so that's why we're allowed to have negative numbers here. So let's take a look at this. Let's go ahead and plot some points. I have 0, 0, which is our point of inflection here. I have -1, -1. I have 1, 1. And then I have 8, 2, -8, -2. So it looks kind of like our normal x cubed function, but now we have the inverse, which again, we've already explored this. We looked at it the past couple of days. We've seen this already, which is kind of cool that now we're putting it all together. Now, our original pattern was right 1, up 1. So that one's going to stay the same, because remember, your inverses change, but when you change them, they're still both 1. Now I'm going to go right, what number? 8, yeah, very good. And up 2. Again, because the pattern was right 2, up 8 in the past. But since we're now in the inverse function, we just switch up. So you really don't have to memorize again. If you just understand that they're inverses of each other, you can just be like, oh, they're inverses, so I'm just going to switch what I've already memorized. Okay, so you already knew that a cubic was right 2, up 8, but now that we're in the inverse function, they're just going to switch. Okay, so that's going to help you out. Okay, questions on that? All right, now let's do some problems. It says graph each function, describe the transformations from your parent function. So we got to actually talk about what they are. And then identify the domain and range and interval notation. Pay close attention to the type of root. Okay, what does that mean? That means look at your index. Okay, make sure that you're in the right index here. What is this imaginary number that's inside this index here? A 2, yes. When you say square root, it's not a 1, it's a 2, technically, but we just don't write that out when we do notations. So let's talk about this one. Now, when we did quadratics, or if you look on the first page, if it was inside the parentheses, which you can kind of treat the radical like it was in parentheses, the inside moved left, right, the outside moved up, down. So what are we doing in this situation? Good, left 5, down 2. Awesome. So guess what we're going to do is we're going to plot exactly what we just said, because that's going to be our vertex point in this situation. Okay, so let's go ahead and plot that. I have left 5, 1, 2, 3, 4, 5, and down 1, 2. Now let me ask you, is it going to look like a quadratic or half a quadratic? Half. Very good. I'm glad that you understood that. Now our pattern. Remember, it's the opposite of what a quadratic is. So when we go right 1, what are we going to do? Yeah, up 1. Now what are we going to do? Because think about that pattern. Yeah, right 4, 1, 2, 3, 4, up 1, 2. And there we go. Again, if you get stuck, you're more than welcome to plot it in your graphing calculator and make sure you're right. Check and see how you did. It's always a good habit to check your answers. Okay, Okay? A lot of you are flying through this already. If you want to go ahead and try the next one, feel free. Because it's very similar. You just got to be careful because now we have a 2 in front. 2 represents something. You want to press math? If you get stuck with patterns, just start putting in points. Find your point of inflection or your vertex point and then go off of that. Okay, it looks like a lot of you are moving on to the third one, so I want to make sure we go over this one. Okay, the transformation. The A value out in front tells us we're either stretching or compressing. And in this situation, you should have been stretching, which really only affects those Y values. Okay, those Y values. So, is my vertex changing in this situation? No, so I'm still going to have 0, 0. I normally go right 1, up 1. Now what am I going to do? Yeah, right 1, up 1, 2. Very good. Really, you're just making this half a parabola get stretched up. It looks like it's wider. Okay, so then usually I go right 8 and go up 2. I messed it up. Right 4, up 2. Now what do? Not 8. Right 4 and up 4. Very good. 1, 2, 3, 4, and up 1, 2, 3, 4. Okay? And if you notice from your original parent graph, it looks like it's wider, which is what stretching is. You're stretching it up. There's one thing I did forget to do, and that was to do your domain and ranges. But I know that you guys are really good at your domain and your range. Let's talk about domain. When I go left to right, because that's what domain is, where am I starting? What'd you say? Yep, -5. And do I include it? Yes. And where does it go? To infinity. Very good. Now let's talk about your range, which is bottom to top. Where do I start? And I go to? Very good. Go ahead and do your domain and range for the next one here. When you're done and when you're done only, take a look up and make sure you did it correctly. Okay, again, if the pattern stumps you, some of you really just do not like patterns. I get that. You can just put in some points. Get your vertex on the graph, which is highly recommended, and then put points on the left or right of it. Or use your graphing calculator to validate what you were doing to make sure that you got it right. Okay, let's look at this cube root because it's a little different. What's going on in our cube root situation here? What are the transformations? Good. This means I'm going right 2, and this means I'm going down 3. That's my point of inflection. The transformations are your point of the inflection if you're moving left, right, down, or up. Okay, so I'm going to go right 2, 1, 2, and I'm going to go down 1, 2, 3. That's that point of inflection where it's going to change directions. Okay, now we just do our pattern. We don't have to do anything else because the only time that affects our pattern is if we're stretching or compressing or reflecting. Okay, so let's go ahead and do our pattern. Our pattern was up 1 over 1. Then it was up how many? Up 2? What's the cube root of 2? Can you do that? It's up 8. 1, 2, 3, 4, 5. Over 1, 2. Did I mess it up? I messed it up. Oh my God, I am thinking it is way too early for me. I am so sorry. Up 2 over 8. You were right the first time. That's my bad. Then we just do the opposite. Something over here. As long as your graph looks something along these lines, we are happy. We should really, 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 really like any kind of odd degree because your end behaviors are always going to be going opposite directions, which means our domain and range is always what? Yeah. All real numbers or negative infinity to positive. Very good. It goes forever up, it goes forever down, it goes forever left, and it goes forever right. It might not look like it's going forever up, but it slowly is in this situation. Okay. Let's talk about these next ones here. What is this negative all the way out in front meaning here? Yeah, reflect over the x-axis. And you want to write that because sometimes we reflect over the y. So is our vertex in this situation going to be changing? Did we move left, right, up, or down anything? No, so we're still going to be at 0, 0. Now, is that negative going to affect my right values or my up values, my x values or my y values? What'd you say? Y, very good. So instead of going right 1, up 1, I'm going to go right 1, what? Very good. And then instead of going right 4, 1, 2, 3, 4, sorry, we are still going right 4, 1, 2, 3, 4, but now I'm going down what? Good, 1, 2. There we go. Okay, so you're really just affecting those y values. So what we did is we went right 1, down 2. We went right 4, right 1, down 1, my bad. Try this next one. It's the same, but now we're not going to be changing the x values. We're going to be changing, sorry, the y values. We're going to be changing the what values? X. Oh. Oh, have you already done with all of these? Save the last one to do together because it could be a little challenging. To validate. To validate it, yes. But we would try to get you to do it independently, but then look at your calculator and make, oh, I messed up somewhere. Where did I go? Yeah, you'll be able to look at it.
Basically on the test, you just need to know what the function is going to look like in general. Like if I asked you, what does a quadratic look like, you can tell me it's going to be that U shape. If I ask you what the square root looks like, okay, just be able to understand what the graph might be able to look like.
Okay, your graph should look something like this. My point of inflection is 0, 0. And because I'm reflecting over the y-axis, if you can imagine, it usually goes this way, and it reflects over the y. It should be looking something like this. So it changes my pattern. Instead of going right 1, I went left 1. Instead of going right 4, I went left 4. And again, the patterns, some people don't like them. It's okay. Point your point of inflection. Like, oh, okay, I kind of know that it should be reflecting over the y-axis, so I know it should be somewhere over here. Maybe I'm going to plot 1. Plug it in. You're going to get those values. Okay, plot -1, I mean. All right, now let's talk about this last one here. What's going, oh, I forgot the domain and range, of course. I keep doing that. I don't know why. Domain of this very first one, going back. When I go left to right, where am I starting? 0, and I'm going where? To infinity. Now let's do range. This is a little bit tougher. I feel like some people can't see it. When I go bottom to top, where am I really starting? Negative infinity. Very good. And I stop where? Where do I stop? 0. So if it helps you, I've done this with some people and it really helped. Some people like to label their axis. This is right here. It kind of helps you visualize. When I go down, up, there is function that's going to be down here eventually. Negative infinity, and I stop at 0. Sometimes that helps you visualize it. Now let's talk about the domain of the second one here. What'd you get? Good. Negative infinity to 0. And again, if you're looking at my axes here, I'm starting, look at the arrow's starting at negative infinity and I'm stopping at 0. What about your range? Very good. Last one, and we're done. Okay. What does this 1/2 all the way out in front mean? Good, I'm compressing. Can it be any fraction in the world to be compressing? Are you sure? Does 4/3, would that be stretching or pressing? Stretching, because 4/3 is bigger than 1. Okay, remember, to compress, you have to be between 0 and 1. Okay, that's what compressing is. What does this 1 represent? Up 1. Remember, I always say, get your point of inflection first. So my point of inflection, my POI, is what? Good, 0, 1. That's my point of inflection. That 1/2 isn't affecting my point of inflection here. So 0, 1. Okay, here we go. Let's do our pattern. I'm going to be going, I normally go up 1, right 1. Now what am I going to do? Up 1. Good. I'm going to go up 1/2 and then what? Yeah, it would still be over 1. Very good. So I'm going to be going up 1/2 and right 1. I definitely probably should have wrote right 1 first, but that's okay. Now, my pattern again is usually going right how much? How much am I usually going right? 8. Okay, so I'm going to still go right 8, but now what am I going to go up? What'd you say? 1. Very good. So I'm going to go up 1. I'm still going to go right 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. But now I'm only going to go up 1. Okay, and then it just kind of flips over that origin. Domain and range of all odd degrees. Yes, question? Interesting. Yeah, because I probably just plotted it. I was just sketching it out. Let me see yours, though. I don't think that's correct. Well, let me just finish this up, and I'll come by your calculator. Okay, what are the domain and range of all odd degrees? All real numbers. Okay. Do you have questions at this point? Some of you might have been confused by the pattern, and that's totally okay. If you hate the pattern, that's fine. You start getting some points on your graph. Okay? You need to know the general look of it, though. Okay, let me see.